paper do you have, or any past paper that you have currently? Have you gone through the past paper? And then maybe you can tell me the issue that you have encountered. Okay, if it is have you checked them? Is there anything that we have not covered? Just a minute. Okay, so I have seen that you had an issue on Dicastra's algorithm, and when you're using the Dicastra's algorithm, this is the algorithm that we said we need to look at now, the strength and the visibility of the processing. And when you're looking at the strength and visibility of processing, I remember there is a time that we used 2R, or we are using some presentation of data, but we are using a base or a base length of a specific data that we had. So I think I can revisit this because I was looking at some questions that we need to look at. We will revisit this. So I'll post it somewhere so that we can revisit that next time. Or maybe after we complete on what we wanted to cover today. So I think, Evans, I have noted this, and we will cover this. The mostly when you're using the base presentation of an algorithm, so we are looking at the bandwidth. So I remember there is somewhere we were using 2B or 2 base in terms of length, in terms of presentation of maybe the wire length that we have. So I think I'll cover that. We will do some calculations on this and I'll be able to understand after that. Is there any issue that we have covered, you have not covered? Mushangi, I think now we are looking at some, question paper that you have gone through. Maybe we look at where we have an issue. Then from there we can start. Because I remember we were saying we need to look at introduction. And then after we look introduction, I'll be able to come to these algorithms that we have here. So Evans, I have noted that. I will repeat that algorithm again. Okay, subnetting. Subnetting is not in your course outline, of which I can tackle that. So maybe we can do this next week. We can do this next week as a topic. Which algorithms? Mushangi. So even subnetting, we will tackle that. We will tackle that from next week. I think we can set that with next week, of which it is not in your course outline, so don't worry. That's why I have not covered that, because I was first covering the ones that are in your course outline, mostly when you are doing some practicals. Which algorithm, Mushangi? This is the Dicastrus algorithm. Yes, okay. That one I have said I will cover. We did it, but I will repeat this. I will repeat it. I will repeat this algorithm again. Is there any other thing that we have covered? Maybe if you can look at the question papers that we have, maybe you can tell me whether you have seen some topics that we have covered, or maybe there is a breakout. Can you answer anything on that question paper that you have already discussed, or maybe you have gone through? Yes. So before we continue, we must look at now the things that we have not covered. That's why I'm asking a question, whether for those question paper that you have gone through, have you checked the question paper maybe and found that there are some things that you are not understanding? Or have you seen that all the question papers that you have, most of them you have covered the notes, or that are in your notes? Evans and Mushangi. Or maybe those are outside the notes. And maybe if you can use your mic, you can still use your mic. Yes, I can see Evans, you are typing. Yes, Faith, Faith, welcome. So we are looking at the questions that we have not covered, or maybe the question that we have covered, but you are not understanding them. Then you are looking at the question papers that we have. Is there any challenge that you have encountered when you are revising? Or if there are challenges, does it mean that it's because you have not covered those topics? Or maybe if you are looking at the notes, we cannot see anything that you can answer through the notes. So that is what we are doing that right now. Because I remember we were supposed to do this last week. I waited for you, and I could not see anybody on that. Okay, if you look at TCP/IP, mostly what we covered about protocols. Then we covered the layers that are supposed to be within the TCP/IP. And if you look at the layers that we covered, we said we have the first one, application, we have the network, internet, etc. And all those are the ones that you are supposed to cover according to the network. And if we are able now to look at now in broad, remember we are supposed to look at in broad, in terms of outside the course outline. We are supposed now to look at now how these protocols are able to communicate with each other. And then what are the presentations of the algorithms that are supposed to be used on the TCP/IP. Then we are supposed to look at the security mechanisms. And I think I looked at the security in terms of how we should be able to protect data on a TCP/IP, and how we should be able to look at in an explanation of how the handshakes are supposed to be used within the communication. And for this case, maybe we can note it somewhere, maybe so that we still go back. Remember, I was doing that because of the course outline, but we can do this now because we have already completed the syllabus. We can now broaden that. After that, maybe you understand on these things. Just a minute. So we look at TCP. So I think those are the things that we need to look at. Yes. Yes, we will look at that. Then there is this algorithm. So that is noted, Evans. That is noted. Yes, Faith, we are waiting for your response because I want to compile them together. Then after that, we'll do one by one. So Ethernet. So Ethernet, we are supposed to cover Ethernet in wireless. That is the case where we have some limitations. And when you talk about Ethernet, we were looking at Ethernet as a way of communication. We look at 2B Ethernet, 2C Ethernet, and many others. That is 802.1B, 802 2B, etc. So that is why we have a remit, of which we will cover that. That is another thing that we need to cover. Yes, Evans, so I think we will still cover that. We will cover that Ethernet. And mostly we will be looking at wireless communication, maybe when you're using cell phones and many other communication that we have. Maybe we are using the wired. What are we supposed to use as an Ethernet communication? So we'll still cover that. Any other Evans? Faith? Mushangi? Yes, Evans. So in Ethernet, we'll be looking at the speed of communication, the speed of data transfer, how data is supposed to be transferred from one point to another. Which Ethernet, does it have a high speed? Is it 2B or is it 2C, etc.? Now, if you look at in mobile phones, in communication, what are we supposed to use in communication? If you use maybe computers, what do you use in communication in terms of speed? And that's why we use the Ethernet standards, ITU as an Ethernet standard, ITU as an Ethernet standard that we should be able to have. So I will still add some things here. We can look at Ethernet standards. Ethernet standards. So we look at Ethernet standards still as part of an addition on that. Yes, Evans? And I'm waiting for others. Maybe Bura Faith, Mushangi. That is about networking. So we need to revisit link state versus distant vectors. These are the mostly used in network communication. Okay, so I'll still cover that. I'll still cover that. So I'll give it one word. I call it network states. Network states. So the next one that I have seen, maybe Faith is asking, is on Ethernet. So mostly when intranet, sorry, extranet. So these are in types of networks that we have of internets. We always say that we have two broad types of internets. One is intranet, and the next one is extranet. So for this one, it is covered in the introduction. So this one, for this case, I did not cover that because I was given this unit when you had already started the class. And I would maybe suggest the one that we are tackling today, that is introduction, we'll be able to look at extranets. And because this is part of what we were supposed to discuss today, when you look at extranet, we are looking at setting an organization, but this organization can be able to access maybe other services outside its organization or its premises. Right now, you can have a library system maybe when you go to Nairobi or when you go to Nyeri, is it possible that you can access services that are in that library? So the only thing that you require is the credentials, and the moment you have those credentials, you can access any services that is in Nyeri, the same way you can access it in Nairobi. So that is a form of extranet. If now you can access services of a given organization, where at home maybe you can access maybe the ZTech University library currently when you're at home, that means you're using what you call the extranet. So in that conversation of an extranet, we always understand that extranet is a way of communicating remotely, and you can be able to serve some communication outside the organization. But intranet is when you can serve an internet within the organization, but you cannot serve it outside the organization. And that's why I look at now maybe the presentation of maybe Audika, the Sable. If you look at maybe I use paint, maybe to define that. If you look at Audi, the Sable of Audika, mostly I want to draw it when it is too large. It is something like that. It looks like that. And for this case, we can say we are having an internet here. We are having an internet here. We are having an internet here. But this internet, you can see it is still bypassing on the other. So this is internet A, and this is internet B. So for this internet A, somebody who is accessing internet A can also access internet B. So this means it is what you call extranet, meaning this is where now somebody else, or maybe you are in a location A, but you can still access the internet that is in location B. So in that case, we are looking at now intercommunication, and it mostly work with remote communication. Like now you are using the ZTech services. This is the platform that for ZTech services, and that forms what you call extranet in that communication. But intranet is a communication that is within a given organization. It is not beyond the organization. It is within the organization. So that is part of what we are supposed to cover today on introduction. And that's why I was asking some questions so that I can prepare myself where to start next time instead of asking you those questions, what you have not covered. And we need to move ahead, and maybe we try to do some thorough revision from that point. So I think, Faith, I have answered your question, and I will still answer that question again the moment we'll be looking at this introduction part that we are supposed to cover. So, Mushangi, is there any question you have? Evans, do you have any question on that? So I will revisit this definition of terms in terms of network communications. So you revisit that. Yes? Yes, Mushangi and Faith, I can see Evans is typing. Eh? So I think as Evans is typing, so I would urge you maybe instead of waiting for long, No, it has some differentiation. It has some differentiations, and it's a very slight differentiation because when you look at the Castra's algorithm, mostly we are looking at the visibility of strength of that wire, or maybe that communication that we are having. But Berelsmann-Ford algorithm, we are looking at now how the cabling connection has impacted on the speed of that communication. So we look at differentiation. It has a very slight difference because in this case, we are looking at the communication, the bandwidth within the communication. But for this case, how has it impacted on that bandwidth communication? So we good revision that you have already done, Evans. That's a good revision that you have done. So we will revisit that. Because Bell's dam, it was, this one is mostly, this was a tradition, but this is the current in most of the protocols or in most of the network services. It must use what you call the Boltzmann-Ford algorithms in that communications. So we will revisit that in that. So if there is any question, please, as we proceed, you can still post using the SMS, the message that you are typing. You can use the message, and maybe we move ahead on that. So I want just to have a representation of the introduction. And I think these ones are not new to you, because when you look at data, we look at, I remember there is a point that I remember asking you, what's the difference between I remember there is a point where I asked you a question, what's the difference between data and what you call signal? If you look at the networking, if you're using the OSI layer and the TCP IP layer, so in this one, we use data, but this is where we need to use some signal in terms of presentations, because this is when we are using the internet communication. So data and signal is something that is totally different, because when you look at data is what should be communicated. Signal is the sign. So we are looking at the sign. So this is the sign of communication. And within the network, in the way we define it in other subjects or in other units, it's the same way we define it in this. But we need to understand it in a broad way, where we need to understand this is something that has to be communicated. So it has a message. And the message is something that is even positive or negative. So in this case, we can say maybe if you're using an ambulance has a message, but we always portray a signal, where maybe when you have a siren, that siren portrays a signal, but whatever it's inside, it's now the data. Maybe this is a person who is dying, or this is a person who has died, or this is maybe some assets that are within the house, the car. So in that case, we can be able to understand that data is something that you cannot see. Data is something that is not meaningful. Data is something that is not arranged. It is not organized. We don't know what is inside. But if you have a signal, you can be able to understand that is something that you can be able to use in communication. Then, when you look at the information, I think this is not new to you. It's something that has been processed. And we always understand some differentiation of communication when you're using this point of data, where we say this is a way that data is supposed to be communicated. It is processed. You can use it for decision making. You can use it for many other aspects that you can have. But with this aspect, we always use data and information for communication. So communication refers to sending data from the sender to the receiver. So we are sending data from the sender to the receiver, from the receiver to the sender. So in that, we are doing what you call exchange of data. So the whole definition of data communication is the exchange of data or information. So we are exchanging, meaning what are we using to exchange? We are using softwares and we are using hardware. And we want to involve some senders here. And that's why we always look at this point. Maybe when you are trying to communicate in this, we always say that we have a sender here, but this sender, so we can use sender, but this sender is sending data. Then from this sender, that's what you call encoding. Encode. And when you encode, we are saying we are creating some forms of communication. We are creating some forms of communication. We are organizing the data that is supposed to be communicated. Then we use what you call communication systems. Then from the communication system, we use what you call decoder. We decode. Then from that, there is what you call the receiver. So in this case, we are saying the communication moves from the sender, but the sender can only understand the possibility of it communicating and can see the communication going to the receiver, but it must pass through the communication systems. So in this communication system is the one that does what you call enciphering. Sometimes we call it transceivers. It acts as a transceiver. It acts as transceiver. Transceiver. So when it is working as a transceiver, it is able to do what you call sending and receiving. So it can respond to a certain event. So transceiver is a way of accepting the input from the sender and from the receiver. So we are doing what you call translation. We are getting some information from the sender and then from the receiver. So in that communication, maybe we can say, maybe we are having a certain cable, and this cable is able to do some communication. How are we supposed to arrange them? Maybe we are arranging them into different bits of zeros, 1, 0, 1 in that communication or in that order. And when you're trying to use that communication in that order, we can be able to understand that this communication is able to intervene, or this system is able to intervene on interpretation, on how it is supposed to be taken to the decoder so that the decoder can interpret or can put it in the form that the receiver will be able to understand. So this is now putting the data into a form that the users will be able to understand. So how will the user understand this data? The user is able to understand this data in a 1212 or maybe 010101. So then the communication system translates that data. When it translates that data, it is converted in a manner that the receiver can be able to receive. And that is where it is taken to the decoder to put it in the form that the user or the receiver is able to receive the data that you have. So in that case, what we can be able to understand within this communication, we can say the data is exchanged in a medium. And which is that medium? Maybe we are using a cable, we are using an Ethernet cable. That is why we are using maybe 8002.11, 8002.1b, 0.11b, 2A, 2C, etc., or 2AB or 2AC, etc. And within that communication, we are able now to get the respective data that we are supposed to get because the system has already communicated on that. So that's why we are saying this process involves a communication system, which you have already done that, which is made up of hardware and software. The hardware part involves the sender and receiver and device, and that mediate through which the data process. It involves certain rules which specify what they communicate and all that. So as we are communicating, remember the data is supposed to be converted, so you need some protocol. So we need to look at the characteristics of this. And one, I think we have looked at the characteristic delivery, because we are looking at now, we are delivering it from point A to point B. Like now, if you take a tin and we are using tin A at this point, and then we have tin B. If you have tin B, so when this person is sending and this person is sending, you first of all wait for this person to complete the sending mode. So in this case, that's why we are saying we are using delivery. So this is part of delivery. If you look at the traditional way of communication, we are using tins. Maybe if I hit the tin in maybe 2 times, maybe that is 1, 2. So it means maybe there is something that is happening. If I am using a drum and maybe I hit it continuously, maybe there is a certain communication. So when you look at this communication, we are moving from sender to the receiver. So how will you get that information? That is what you call delivery. We're looking at accuracy. And as I use the older method of communication, and I'm using a drum and I hit it twice. Maybe if I can say the first one, the 2 times is a person who has died. Maybe if I hit it 4 times or 3 times, there is a wedding in that village. So if I hit 3, people will now interpret that message as this person is having a wedding. But if you go to that premise, you find that there is somebody who has died. So how will you interpret that? So the way we interpret a message should be very accurate. It should be away from errors. It should be corrupt. It should not be corrupt with errors. And that's why we look at various aspects of communication. And I remember we said one way, the way data can be corrupt. It's because of one, distortion. 2, you can have what you call attenuation. Now, what result to this distortion? Distortion is when you look at now, there is disturbance. Let me use that one. Disturbance. So there is disturbance in communication. Maybe there is a sound that is coming because of maybe drilling. We are drilling. Because of object moving. That one can result to distortion. And I think you have ever tried to communicate using a mobile phone, and you find that now sometimes you are not even clear. There is that loss of data. So in this case, the attenuation is the loss of data. The loss of data. Where distortion is when there is a communication, but this communication is not clear. It has some disturbance. Maybe there is a background sound. Maybe there is a background thing that is happening. Maybe drilling. There is somebody who is doing some drilling. So you can hear drilling, or you can hear some other communication that are not relevant within the background that we have. But when you look at the attenuation is the loss of data. It is the loss of data because of the length of the wire, the length of the cable, the length of cable. So the cable is too long to communicate. And that's why we always say that maybe you use 100 meters a cabling, because you don't want to have what you call loss of data. I want to take you back. Maybe the moment we are using the mobile communication, and we are using a point of communication where the network coverage is very strong. Then when you move far away from the network coverage, you find that there is loss of signal. You are communicating, but this person is not clear. It's like now you are demeaning the communication. You are reducing the communication. This reduction of communication is the one that results to this, what you call jittering. And we have said is a variation of packet arrival time. So you find that I think you have ever even had maybe the attenuation can result to a jitter, where jitters is sometimes you find that somebody is listening to a radio, but we are reading news, but one person is starting news. But as you are starting, you find that maybe in another house, the news has not started and you're using the same station. Then after 5 minutes, you hear that this person has now started receiving some news. So you find that now this communication resort to what you call jitters. So in this, when you talk about the mobile phone, we are looking at a point where we are moving away from the communication. And when you are moving away from the communication, one can either be result of, because in a mobile phone we don't have cabling, we are looking at maybe the distance. So we can also say that distance is a point of communication that can result to what you call attenuation. So the length of cables, distance. So distance in terms of cabling, because distance can be applied in cabling, or distance in terms of wireless communication, meaning that you are very far from the communication. We are starting communicating here, but you are very far from the communication. That means you cannot hear what I'm talking about in that time or at that time. So that is now one aspect that you should be able to understand, that as you look at the accuracy, are we resorting to attenuation? Are we resorting to distortion of the message that we are having within the communication? That's why we find that now we always need to resolve these issues. One, we need to resolve issues by making sure that the length is too small of that cabling, or we are not far away from the network communication. Sometimes if you look at the mobile phone, and we have seen this, if you go in high areas or high-rand areas, or maybe if you move to a very remote areas where the houses are very far from each other, or maybe we have an island, you find that the communication is having a problem. When you move to a place where there is cloud, or maybe there is climate change, every time you have a climate change, maybe in Mount Kenya region, you always find that there are some issues of climate. Sometimes you find that the network coverage is very low. So where there is some effect of climate, it keeps on changing one at a time. You find that now this climate changes the network communication. That's why even if your booster or the line of sight or the booster is within your premise, you can still find that now the communication is not clear because of that climate, because it is affected by the climate. So that is about the wireless communication. But in a wired communication, we have said it is when you have a very long wire, and this very long wire is not able to allow the communication very effectively. So in this case, you resort to some issues of communication. You resort to some disturbance of communication. Maybe we have some background errors, or maybe you are trying to communicate with somebody who is near. Sometimes you not even hear. You'll be hearing a real voice, but not a distributed voice through some data communication. So those are some effects that you always resort because of inaccuracy. And that's why we always say that in data communication, we should always observe what you call accuracy of data. Then the next one is timeless. And when you talk about timeless, is setting the data that is given in the real time, or maybe that is expected to be gotten at that time. So it's like a message. You're not supposed to send a message that is very old, if I can use that in quote, meaning that if you look at the properties of a message or an information, the information should be accurate, should be relevant, should be meaningful. That is what you call timeless. So that message should be sent the time that is supposed to be sent. So when you're using this communication, it should be sent at the same time. So that's why we are saying real time. Jitters, sometimes we look at jitters, it's a variation in the packet arrival time. And when you look at this arrival time, we have looked at this as a problem in the communication, but this one can be a way of understanding how the data is supposed to be communicated on that. Because we are looking at a point where even if we are sending these packets differently, like now the one who is receiving a news earlier than the other, you should not receive news that are totally different. They should be the same. So in this case, even if the packet arrival is deviating some time arrival, automatically you should always be able to observe that this should be able to work within the timeline that is supposed to work within that. And jitters mostly affect the time, because now if this news was supposed to be received after 5 hours, now this person will maybe end this news after 10 hours, because now there is an unended time that has already been added. So I think this one you covered, and that's why I'm rushing for that, because this is just a recap of what you did. And within this, we can be able to understand that when you use a communication, this one has some component. I think we have talked about this component. One of them is the sender, the next one is the receiver. You can have encoding, you can have a communication system, because these are people who are receiving some data. So within the communication, we have people, we have hardware, we have softwares that are supposed to be used in communications. And then we have some protocols that are supposed to be used in the communication. So we can look at this component. One of them is a message. The second one is the sender. The second one is the receiver. The next one is the protocols. And then we can look at the systems that we are supposed to use in communication. So this question is very common in networking. Sometimes you can be asked, the components of data communication. So one of them is a message. The information to be communicated. Maybe you're looking at the sender, whoever is supposed to send some information, receiver, whoever is supposed to receive the message. And then we have the transmission medium. These are the systems that we are talking about. Mostly we are looking at the cables, we are looking at the hardware, we are looking at the softwares that are supposed to work within that. So we are looking at the path of the mediums. And in this case, maybe we are looking at the Ethernets that we are supposed to use in communication. Maybe you are looking at the Ethernet that has already been given a certain protocol to use. When you look at the protocol, these are the rules in the communications. And I remember when we were talking about these rules, we are saying there is SMTP, Simple Mail Transfer Protocol, File Transfer Protocol, Transfer Control Protocol, Internet Protocol, Telnet protocols, and many other protocols that we talked about, HTTP protocols. And those protocols are always observed within a given area of communication. So protocol is one of the important parts in communication, because as we are communicating right now, we are using a certain protocol. And this protocol that we are using currently is what you call a telnet protocol. And this telnet protocol is allowing us to create some intercommunication, or it is allowing us to allow users to maybe to associate with a defined communication from one area to another. So that's why we say that most of these protocols that we are supposed to have, they are able to work within a certain socket. Either one is working with a 54, that is HTTP. Maybe you're using the telnet, which is working within the port 23. SMTP, which is working within 22. Maybe Simple Mail Transfer Protocol, which is acting within the 24. And many others that we have as a socket in terms of communication. And that's why I remember we talked about others, maybe we had others like the datagram protocols that are mostly used in transport communications. We had HTTP, which we used it in application protocol, application layer in terms of communications. And what I would urge you to do is that all the protocols that we discussed when you are looking at the OSI layer and the TCP layer, make sure that you understand where the protocols are used, or where the protocols are implemented within the layer. Is it implemented in the application layer? Is it implemented in the transport layer? Is it implemented in maybe the application layer or any other layer that we have within the TCP IP and the OSI layer? So those are few interpretation of what we mean about protocols. And now when you have protocols, you can look at another transmission, that is data representation. Maybe you present data in terms of text, in terms of numbers, you present in terms of images, and many others that we have, audios, videos. I know that these are common formats, and because you are doing what you call what? IP. Is it called what? There is this unit that you are doing which is called internet, IP, something like that. And this unit that you are covering, you have already talked about these in terms of presentation. So I will not talk about these in terms of communication. So you'll be able to understand that when you are presenting data, you either present text, you either present audio, maybe you either present videos, and you either present images, you either present numbers, etc. So the next one is about data flow, and I think you covered this. Did you cover this? You cover this on Simplex. Did you cover that? So I'm waiting for an answer. Maybe we can brainstorm on that. Did you cover that? Did you cover this topic? Data flow. Ian, you think so? Well, you're not revising. Ian. Okay. Evans, did you cover that? Okay, we can do this. We can cover this. So when you look at data flow, you can always classify them into three. Simplex, half duplex, and full duplex. And in this case, we are looking at which device is able to send and receive the data. And when it is sending, remember that it's like we are having two devices, the sender device and the receiver device. So in a simplex, it's a very simple communication. Because in this case, we are looking at unidirectional communication, where there is one person who is sending and there is another person who is receiving. Just that. And right now, if you look at a mobile phone allows you to receive and allows you to send. So that one cannot be a simplex communication. That one can be a full duplex communication because it is allowing you to communicate and it's allowing you to receive. When I'm using a keyboard, I'm typing something. That is a simplex because you must type so that the other person or the other device can allow or can receive the information. So for this case, we have talked about the CPU. So the CPU is directing data to the monitor. So that's when you can receive. So if the CPU have not directed the data to the CPU, to the monitor, automatically you cannot receive the data. So when you look at simplex, is unidirection. That is one-way communication. One-way communication. So you cannot have two-way. So a simple presentation of that, or a simple definition for that, we can say it is a one-way device communication or a one-way of communication, meaning only one device sends the data and the other one receives the data. So one is when I'm using a keyboard typing the data, or maybe when the CPU is sending some data to the monitor, and whatever you see is what you get. on that. Then the next one is half duplex. So in a half duplex, you can say it is a two-way communication. So you can say it's a bidirectional communication. But in this case, we have some difference in this with the first one and the second one. When you use the first one, simplex, it's one way. You cannot get back to the CPU. If the CPU has already sent data, that is the end. But when you look at this, you have two-way. When the sender has sent the data, or the station 1 has sent the data to the station B, the station B can still send back to the station A. But the problem is you have to wait until this person completes the execution, like a walkie-talkie. When you look at the walkie-talkie, you always send data, but this person who is sending data, when he is over, he says over, meaning you can now allow the other person to communicate. So you cannot have two-way communication. You cannot have two people communicating at the same time in that way. So one has to communicate first, then the next one has to communicate afterwards. So that's why we are saying an example of this is what you call the walkie-talkie. When one device is sending, other can only receive, and vice versa. So if you look at this diagram that we are having here, we are having here, we only have a half duplex, as where station 1 and station 2, station 1 is sending data and station 2 is receiving. So station 2 cannot send when station 1 is sending. So it must wait for station 1 to complete sending the data. And when the station 1 complete, automatically station 1 said end of communication. So that is one of the disadvantages that we have. You look at now a point where you are sending data. If now the network ends at that point, so automatically the receiver will not send that information. That's why we have what you call the full duplex. And in a full duplex is when you can send and receive at the same time. When you are talking using your mobile phone, automatically you can create a conversation where this one is said, where we are talking at the same time and we are not affected. The only thing that we find there is distortion, because now there is one person who is talking, the other one is still talking, and when two people are talking at the same time, you find that now in that juncture, you find that now there is a loss of communication, because one person is not is receiving, yes, but we are not listening to what this person is saying. So in this case, we have said one example is the mobile phone, which allows you to communicate. You can, maybe it's like we are fighting with you, and when we are fighting together, maybe we are using the ones of fighting. Remember, I am giving you a message the same time you are giving. So we don't have a forum of communication. We don't have a step or a procedure of communication. So in that case, we say we are using what you call a full duplex. A full duplex. So maybe you can ask a question at that point, maybe as we proceed to the computer networks, the classification of computer networks, and other things that you are supposed to cover on introduction. So I think you can ask some questions from there. You can ask some questions. You can ask some questions. Okay, I will share the notes. I will share those notes after this class. Any other question? So up to that point, there is no question. So I think I will send those notes. I will send those notes. So the next part that we are supposed to cover or to look at, that is a recap, is computer networks. And I think up to now, you know what are computer networks. And you know the services that are supposed to be on an internet or on a network. And maybe if you look at this, we always say it's a correction of computers, one computer with another computer. So it's the correction of computers. And that's why we are saying that. So in networking, nodes are referred to as computer or the end communication. And that is why we say that is data communication equipment. There are two things that we are supposed to understand within the network. One is what you call data communication equipment and data terminal equipment, DTE. So we have data communication equipment or equipments, and we have data terminal equipment. So data terminal equipments are like the nodes. Those are at the end, from the receiver end and the sender's ends. Those are the ones that we call the data terminal equipment. Data communication equipment are most of the softwares that we use to communicate. Maybe you're using a cable, that becomes a data communication equipment, which is allowing you to communicate from one point to another. So in this case, if you can understand this communication, we are saying a node can be any device capable of transmitting or receiving. So that's why we are saying that can be a data terminating equipment or data termination equipment. You should ensure that when you're communicating, the data is reliable, security, performance. But now the question that you're supposed to ask yourself, which device improves on performance? That is the cable. If the cable is too short, is it delaying in the communication? If it is too large, if it is improper, terminated, is it resulting to some issues in communication? Is it reliable? Can it send the data as it's required? So it should be able to send the data as required, and it should be able to send the data to the destination computer. Then we have categories. In this case, I don't want to call these categories. I want to broadly classify the categories into two. So we have classifications of networks. And maybe we have types of networks. So in this classification of networks, we will call it peer-to-peer networks. And then we will have what you call server-based networks. So those are two classifications. Then when you talk about types, we will talk about LAN. We talk about WAN, we talk about MAN, etc. Campus area network, CAN. We talk about personal area networks, etc. And if you look at these two, peer-to-peer is when you are talking about a computer, and this computer that you are having, or maybe the communication networks that you are having, is able to communicate from one point to another. So we are having point A and communicating with point B. So this is a point-to-point. So when you look at point-to-point, there are some things that we need to understand within point to point. One, no administrator required. No administrator required. Because when you connect computer, like now when you are doing what you call tethering, you don't require an administrator. You can communicate directly. So cost is less or less cost. Because in this case, we only require 2 devices. We don't even require, we only require 2 computers. We don't even require a device. Like maybe we don't require a router. Maybe we don't require a switch. We can communicate directly with one computer with another computer in that. And when you look at this, there is no security. So as a disadvantage, there is no security. No security. Why do we have less security, or we don't have even security at this point? Why don't we have a security at that point? It's because when you look at when I'm communicating with you, automatically, if I want to communicate with another person, I have to create another password. So it's like I'm doing some tethering, but this tethering that I'm doing, I have to create some communication. But each and every person can receive data at any point. So you can receive my data, I can receive your data, I can even access your computer, even if you have not even told me to access it, because I have already been given some way of communication. But the moment you talk about server-based, there is a point where if you're moving from point A, you must move from point A to B, but in this case, you must use a hub or a switch. So from point A to B, then from point B to hub, from point A to hub. So in this communication, we cannot try to create some communication from one device to another. We have first of one device to another, one computer to another, because these are computers, but this is a device. Remember, in a networking, devices are like routers, repeaters, hubs, switches, or many other devices that we have, but this becomes a node. So when you are communicating, this node that we are having here, first of all, it must pass through the hub. This one must pass through the hub. So when you are doing this communication, automatically, if there is security, here we need an administrator, because an administrator is the person who will be able to look at now which device is having some access at that point, where will you have an access at that point, controls the access in a given point, make sure that the devices are able to communicate in the right way, and making sure that communication is up to the standard. So you look at now, here we require an administrator, so the cost is too high. And because the cost is too high, now we find that now it is more secure. So all these disadvantages this disadvantage that we have here becomes an advantage where we have security in this, because now we are looking at devices, they have to respond to a certain device first. There is a central communication, and that is why in most of these network types that we have, they always communicate within these 2 types of communications. And I remember we said that when you're using this, we must still understand that there are topologies used. And one of the topology that is used is what you call the bus topology, ring, star topology, etc. Tree topology, mesh topology, etc. So in this case, if you look at the types, one of them is LAN. Is when you are communicating in a very short distance, or maybe you are looking at a single building. Maybe you are looking at a point where these people are able to communicate, but the moment they are communicating, they are able to communicate within a confined area. So either we are using a peer-to-peer, but in most cases, they use what you call the server-based, because when you're using this, it's like we are having 10 computers in communication, At the moment we are having these computers in communications, how are they supposed to communicate from one point to another? So in this case, in LAN topologies, in that LAN networks, we use bus topology, ring topology, star topology as one way of communication. But the first thing that you're supposed to understand within this, you're supposed to understand one thing is the media or the communications. So you look at the communications, we look at the topography or the topologies, then we look at the size of that network. Is it too large or too small? If it is too large, what can we use so that we can be able to have a clear communication? So in this case, we are saying it is usually limited to a few kilometers of area. It may be privately owned and could be a network inside an office in that. So in this case, we are looking at a point where maybe we can use one of them. Maybe we are using a bus topology. The moment we are using a bus topology, what we always understand in a bus topology is where we have a cable. We call it a component. And this component that we are having, it has another computer here. Maybe you have another computer here. That is what we said in the communication. Then we have another here. So this becomes a terminator. A terminator. And this terminator prevent bouncing back of signal. And when it prevents bouncing back of signal, it is preventing the signal from creating some distortions. Meaning, if there's the computer that is sending the data, it broadcasts to all computers. And when it broadcasts to all computers, you find that this computer and this computer can receive the message that was sent by this computer. And if it can receive the message that was sent by this computer, so automatically you find that there are some issues of communication because there is no secret in communication. So in this case, that's why we have the traffic within this, because this might be sending the data, this might be sending the data, but while they are sending at all times, they are broadcasting. So meaning there is a lot of traffic in communication. And this traffic can only be reduced by making sure that we have what you call the carrier sense multiple access with collision detection and collision avoidance. Or you can use what you call the access point. When you use carrier sense multiple access with collision avoidance, we avoid this, and that is when one computer listens to the network cabling, and then if it finds that there is a person who is sending, or maybe there is a network that is sending, or a computer that is sending, it sends an intent to send a message. And when it sends an intent to send a message, no other computer is supposed to send this message. So in this case, we can be able to detect the communication. And when you send an intent to send a message, you are doing what we call collision detection. Collision avoidance is when you listen, but you don't send anything. So you find that the moment you go back to send an information, you might see even there is a computer which has already sent that information. So in this case, you find that there are some problems of communication. But we have others. I don't want to expound on that unless maybe you tell me you have some issues on these topologies. Maybe how to implement bus topology, how to implement ring topology, how to implement star topology, and many other topologies that we have. Maybe we can brainstorm on this. You tell me whether there are some challenges on this, on these topologies. Are there challenges on these topologies? Yes, Kerry has said no issue. So sometimes you can be given 6 marks and you are told, can you implement the star topology? So I think that is okay. Evans, Faith, Mushangi, Morris. Yes, you can be told to classify them or to relate them with classification of networks. Sometimes, of which this is a direct question. I don't see them asking you a question on maybe classify them into different types of classifications, because in this case, we only have two, peer-to-peer, that is point-to-point, and the next one that we have is what you call server-based. And when you talk about server-based, you know that if you're using a connection of many computers, you must use a server. So I think it's very hard. That is a very direct question. I don't expect maybe them to ask you a question on maybe can you define or maybe can you explain types of network with different classifications. I don't see on that. For this point, that one is a very simple question to you. But if they ask you, I think you can answer that. So Jaggy Morris has said implementation. So when I talk about implementation, I'm looking at now, if I look at the bus topology that I have already discussed here, I'm looking at the diagram that is presented. Then I look at now the explanation on how it is implemented. So the explanation on how it is implemented means the explanation on how it works with this computer, or how the computers are able to communicate with each other. So in that aspect, you'll be able to look at now to explain from one point to another how these computers are able to communicate with each other. That is about implementation. So for this case, I would say it's a mesh because of faster communication. But when you look at this, we always use what you call the star topology. We use the star topology. So in terms of security for the organization, most of the organization uses star topology. But if you are using the best one to communicate, because of depending on the number of computers that you have, if you have millions of computers communicating, mesh is the best. But now the issue is where will you lay out the cabling? Because you are connecting, if it is 49 computers, we are connecting one computer with 48 computers. So it means connection is a problem because of the space. But if you look at most of the organization, they uses what you call the star topology because they use a switch. That's why you find that in most of the organization uses a switch in connection. And it is very easy now to look at now which computer has an issue within the security. So you can look at now, there is a way that you can tap and you see there is a computer that has an issue in communication. It is easy to troubleshoot because now if you find that all the computers are communicating and it's only one computer which has an issue, so automatically it is either the cable which has an issue or it is the port that has to be used has an issue. So in that case, you can be able to rectify the issue very easily. It's not like a bus topology, where the bus topology, you have to move from one computer to another and looking at which computer has an issue. So in this case, you find that now when you're using star topology is the best in terms of communication, because when you use a ring topology, you find that now computer one is connected to computer two. So it means if one computer fails, or other computer fails, and you always expect to have that. That's why it still introduces us to what you call campus area network, where in a campus area network, you can define them into departments. Maybe you have department of hospitality, you have department of management. So in those departments that we have, maybe department of hospitality, it has its own network, but there is a mother of that network, or there is the whole network. So in this case, we can be able to understand that hospitality has its own network. So if now in ICT, the network fails, so automatically the network in the hospitality will not fail. It will still communicate in that. So for this case, Evans, the answer is the star topology. Any other? Any other question? Evans, have I answered your question maybe? Any other question? I think maybe we can get that. What about hybrid? Oh, okay. When you talk about hybrid, is when you're looking at different network communication. It's like now we are having, maybe I can use a very simple presentation here. We can use a component here, terms of communication. But in this case, we are now introducing maybe a bus, or we are introducing a ring. So in this case, we can introduce a bus topology. etc. So in this case, what we are saying is that is when various networks has been connected. There are various networks that has been connected. And that is why we use a backbone. We use a backbone to hold all the networks. We use a backbone to hold all the networks for communication. Just a minute. So just a minute, I'll give me 2 minutes. We can always understand. Okay, I will come back to this, Evans, on physical and logical topologies. I will come to that. So if you look at this communication, we are saying we are having a broad communication. It's like now an entire city. Like now, maybe we are having Nairobi. So you connect all the, how many computers are connected there? How many networks do we have there? So we have millions of them. So if you look at the metropolitan, you are looking at the continent, maybe countries like Kenya, maybe Africa. So how many computers? So the security is still improving, and we need more security. So this one you require a lot of security. This one is minimal. Here we don't even require more of intervention within the security because the network is too small. Remember when we are talking about wireless technologies that we talked about? Not wireless, sorry. The technologies that are mostly used on WAN and on a LAN. So those technologies are still implemented on metropolitan area network because of that intervention. And when you are trying to communicate, remember that you are supposed to use some protocols. I don't want to repeat this because I remember this is the topic that I started with on protocols. And I would want to give you some minutes, maybe I give you some, maybe from next week, maybe you can conduct on this. You look at which are these topologies that you cannot understand or how they are supposed to be implemented. Remember, there are other standards, and I remember I said that we look at these standards. The moment we'll be looking at Ethernet, and these are the approved standards in the whole world that are mostly used for cabling purposes within the network. So I think we'll be able to work with that. So that is part of the introduction that we are supposed to cover on that communication. But I want to go back to this question that was asked by Evans. And the question was, difference between physical and logical topology. So if you look at physical, that is the arrangement of computers, like now, the one that I have arranged here, this is physical. But the moment you are looking at the communication from this computer to this computer and this computer to this computer, we always find some disgrace of the communication. And the disgrace of the communication is where we find that now this computer is sending and this one is sending. So in that part of communication, that is what we call the logical communication, the flow of data when the network is communicating or when the computer is communicating. So the moment I will be talking about networks, be understanding that I'm talking about the computers. So in networking, we say that networks are the computers that are connected. So how many computers have you connected? So in this case, we are following which logic of communication? Remember, we need to use a server somewhere here. And maybe this server, we need to communicate to this computer or maybe to this path, which can be able to communicate to other computers that are connected. So that is a structural way of arranging that. So most of the computers receive some information from the hub. Then from the hub, they will be able to receive from the router. So we have the router, where the router now takes the information to the hub, where now the hub takes to the component or the network connection, and now it can be able to allow the communication of these computers that we have. So that is what we are supposed to expect within the introduction. Unless there is a question, maybe you can ask, or if you have not understood that, maybe you can ask that. Yes, Evans, are you okay with that now? The differentiation between logical and physical. Are you okay with that? Maurice, I think are you okay? Okay. So I want to give you some assignment that I want you to do right now. I know there are some people who have not discussed or have not gone through the questions papers. So for those questions papers that you have, can you go through them? Because I have only received some information from Evans. And these are the ones that we'll be covering from next time. And we'll start from subnetting. I want to start from subnetting. We'll start from subnetting. Then after that, we go to TCP/IP. Remember this one you had already covered up to the standard that we are supposed to cover that time. But I would maybe like to start on subnetting and many other things that we'll discuss here. So I have only received some comments from one student who is Evans. Maybe if you have some challenging questions, let's air them out so that we can discuss them next time. Are you okay with that? So I want to give you time so that we can discuss that. So can we adjourn the class up to next week? So please, next week, I expect everybody to attend the class. Remember, your exam is near. When are you doing your exam? I think September, if I'm not wrong. So I think TVET has already confirmed. Maybe we can sit for that exam of September, maybe. But we'll wait. Maybe we can be told when we will sit for that exam. But remember, as we fail to come to this class, automatically we have to miss the classes or maybe the points that we have already discussed. So let us meet next week for the other class. So Evans, I'll go through the questions that you have already asked, and we will revise them next week.